10.7 covers special segments in a circle. We will find measures of segments that intersect in the interior of a circle and the measure of segments that intersect in the exterior of a circle. The star is inscribed in a circle. It was formed by intersecting chords. Segments AD and EB are of two of those chords. When two chords intersect, four smaller segments are defined. So looking at these two chords intersecting, we would have EF and FB or AF and FD. If two chords intersect in a circle, then the products of the measures of the segments of the chords are equal. So they have AE times EC is equal to BE times ED. Find X. I love those directions. So using theorem 1015, we can write our equation. 8 times X equals 12 times 9. And 12 times 9 is 108. Divide both sides by 8, and we get X equals 13.5. Not bad. Biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Determine the length of the organism if it is located 0.25 millimeters from the bottom of the field of view, round to the nearest hundredth. Okay, not the most helpful diagram. Let's get a better one. Now, earlier in the book, we talked about when we're measuring a distance, we want it to be perpendicular to the thing we're measuring. And then Theorem 10.3 from Lesson 10.3 said that in a circle, if it is perpendicular to the chord, which we just said it would have to be, it's going to bisect it. So that's how they labeled both sides the same thing. They're both X. And if the entire diameter was 2, it's not a big leap to get EB here to be 1.75. 2 minus 2.25. Now that we have it set up, using this lesson's theorem is not too bad. So we're going to have X squared equals 1.75 times 0.25 is 0.34375, and then take the square root of both sides, and we only need the positive square root because we are using measurement. And it said to round to the nearest hundredth, so I should have done approximately equal to 0.66, and our units were millimeters. Okay, those were two segments intersecting inside the circle. Next, we're going to look at segments that intersect outside. Non-parallel chords of a circle can be extended to form secants that intersect in the exterior of a circle. The special relationship among secant segments excludes the chord. If two secant segments are drawn to a circle from an exterior point, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. This is a simpler way that I like to say it. We talk about the equation is the product of the exterior part and the whole segment equals exterior times whole segment. Find X. All right, so we have exterior on EI is 8 times the whole segment be 8 plus X, or X plus 8, doesn't matter, equals exterior on EG is 10 times the whole length of EG would be 10 plus 24 is 34. So distributing, I have 64 plus 8X equals 340. Subtract 64 from both sides. So 8X equals 276. And divide by 8. And we get X equals 34.5. And we have one more theorem to do. If a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the measurement of the tangent segment is equal to the product of the measures of the secant segment and the external secant segment. in my mind, this is the same as theorem 1016. I'm going to do exterior times whole length. So whole length would be x plus x would be 2x plus 2 equals exterior times whole length happens to also be x plus 4 because there is no interior. Okay, a true mathematician would probably be cringing because I just did that, but it makes sense to me. Okay, so distributing, I have 2x squared plus 2x equals x squared plus 4x plus another 4x plus 16. When we combine our like terms, we have 2x squared plus 2x, and our perfect square binomial, first term squared, first times second times 2, plus second term squared. We get everything on one side of the equation, so subtract x squared, subtract 8x, and subtract 16. So now we have a quadratic equation. We need a factor, so I need to come up with factors of negative 16 to give me a sum of negative 6. So negative 8 and positive 2 will do. So I get x equals 8, makes the first term 0, or negative 2 makes the second factor 0. I want a length, so I am throwing out the negative 2 because I can't have a negative 2 length. So 8 is my only answer that makes sense. In summary, the lengths of intersecting chords in a circle can be found by using the products of the measures of the segments. The secant segment product also applies to the segments that intersect outside the circle and to the secant segment and a tangent.